In chemistry, precision matters. Whether you're measuring a reactant, calculating molarity, or reporting experimental results, your numbers need to reflect the limits of your instruments and the quality of your data. This is where significant figures comes in. They tell the world how confident you are about the digits you report. Significant figures, often called sig figs, are the digits in a number that carry meaning about its precision. With more significant digits, the value will be more precise, and with less significant digits, the value will be less precise. For example, if you say a solution's volume is 2.1 milliliters, that's different from saying it's 2.15 milliliters. These different values can come from two different graduated cylinders used. With one graduated cylinder, it could only have the ones place shown as the exact digit, and the other graduated cylinder could have the tens place shown as the exact digit. We will always have an uncertain digit after the exact digit, and the uncertain digit is the guessing digit. The graduated cylinder with 2.15 milliliters is reporting more significant figures, so this will be a more precise value. And the graduated cylinder with 2.1 milliliters has less significant figures and will have a less precise value. Significant figures will be so important so we know the degree of uncertainty that we have for each device that we are using to measure in chemistry. Every measurement has some degree of uncertainty. No measuring device is perfect, and no human eye is perfect. Sig figs are how we express that uncertainty honestly. If two different labs are carrying out the same experiment, but one lab has a more precise scale, the results of the lab with the more precise scale would be trusted more. The only way to know this precision would be to have this system of significant figures of how we report values in chemistry. Many books use a different way to express significant figure rules, but these two rules can condense them so counting significant figures will be more efficient and easier to understand. When counting significant figures, if there is a decimal place, we will start counting at the first non-zero digit and then count until the end of the number, and if there is not a decimal place, we will start counting at the first non-zero digit and stop counting at the last non-zero digit. In this example, we are going to use the two rules that we have to figure out how many significant figures are in each of the following numbers. For the first number, 0.00450, I'm going to start scanning from left to right, so the first non-zero digit that we see will be the 4. I'm going to start counting at the 4 and stop counting at the end of the number because this has a decimal place. Counting those values, we have 3 sig figs. For the next number, there is no decimal place, so starting from the left, I'm going to start counting at the first non-zero digit and stop counting at the last non-zero digit. This one will only have 2 sig figs. For the last value, there is a decimal place, so I'm going to start counting at the 1, the first non-zero digit, and keep counting until the end of the number. And this value will have 4 sig figs. For the next number, there is a decimal place, so starting from the left, I'm going to start counting at the first non-zero digit, the 1, and then keep counting until the end of the number. This value will have 4 sig figs. For the next number, there is a decimal place, so starting from the left, the first non-zero digit will be the 2, and then I'll count until the end of the number. This value will also have 4 sig figs. With 23,000, there is no decimal place, so starting from the left, I'm going to start counting at the first non-zero digit, the 2, and stop counting at the last non-zero digit, the 3. This value only has 2 sig figs. For the next number, there is a decimal place, so I'm going to start counting at the 2 and then keep counting until the end of the number. This value has 5 sig figs. For the next number, there is also a decimal place, so I'm going to start counting at the 2 and then keep counting until the end of the number. This value also has 5 sig figs. The last value also has a decimal place, so I'm going to start counting at the 5 and then keep counting until the end of the number. This value will have 5 sig figs as well. When using different measuring tools, we have to look at how many digits we have to be able to report the correct amount of sig figs. We're going to use the device to read the amount shown using the last place value that can be seen. Then we're going to add one more digit or one more place value for the uncertain digit, and this will be called the guessing digit. For the ruler shown, I can see that we have the ones place, and we also have the tens place. The uncertain digit, or our guessing digit, is going to be the hundreds place. So we're going to report the final value to the hundreds place. We're going to report to the hundreds place because we know for certain where the tens place will be on the ruler, but the extra that we can't see is going to be what we're going to try to estimate to get the best reading for what we see on the ruler. Each tick mark after 1 is going to be 0.1, 0.2, 0.3, 0.4. So I have a value that will be 1.4, and next is going to be the guessing digit. It's closer to 1.4 than 1.5, so I'm going to assume that it's about 1.42. There should be some room for error for the guessing digit because it is going to be our uncertain digit, but as long as we get close to a reasonable answer, they're going to accept it on the test. When we're doing calculations in chemistry, we're going to have to round off the value that we get from the calculator to be able to report to the correct number of significant figures for the problem. We're going to practice rounding off each value to the correct number of significant figures indicated. For the first value, I have a decimal place, so I'm going to start counting at the first non-zero digit, and that'll be the 4, and stop counting after the 5, so I only have 2 significant figures shown. To know if I need to round up or keep the 5 the same, we're going to look at the number right after the 5, and that'll be the 6. If the value after is 5 or above, we're going to round up. If it's 4 or below, we're going to keep it the same. 6 is going to be 5 or above, so the answer that we have is 0.0046. For the next value, I have 3 significant figures, so I'm going to start counting at the 1 and stop counting at the 3. 4 will fall under the second rule. We're going to keep the 3 the same, so the value will be 1, 2, 3 with 2 zeros. Having the 2 zeros shown without the decimal place will be a good option because this will only have 3 significant figures, or you can convert it to scientific notation, and it will be 1.23 times 10 to the 4th. For the next value, we have 0.020498, and there is a decimal place, so I'm going to start counting at the first non-zero digit, the 2, and count 3 digits for the 3 sig figs. 9 is going to be 5 or above, so I'm going to round the 4 to a 5, and the value will be 0.0205. For the next number, I have 987.654, so I'm going to start counting at the 9 and stop counting at the 6 for 4 sig figs. 5 will be the first rule, 5 or above, so I'm going to round up, and the value will be 987.7.